Okay, I'm going to attempt my own little Mythbusters experiment here. I've got two containers, both of them equally container-like. One's marked hot, one's marked cold. Okay, so I'm going to run over and fill them up with tap water real quick. Okay, now they're both full of water. I'll try to get this so that you can read it. It's reading about, the max is 114.5. And that one read about, okay, hold on. Oh. That one read about 50 degrees. So the cold is cold and the hot is hot. Now I'm going to go set them outside and we'll see what happens. I just stuck them outside and you can see it is about 9:40 or 7:45. I woke up way too early. So, see, there they are. Trying to zoom in. I can't remember how to. And there they are sitting on the grill. And just so that you know, boy. Trying to focus on the, there we go. It's a whopping 63.9 degrees in the house and 10.4 degrees outside. So I will try to check on everything every 5 minutes and we'll see where this goes. Okay, it's been maybe 10 minutes. And I was going to see if I can't get this to the warm water that was at 110 is now at 74, and the cold water is reading about 46, 53. The temperature hasn't changed much in the cold water. But it has changed in the warm water quite a bit. It's dropped like 30 degrees. So we'll see what happens. Okay, here we are again. One thing I want to point out is that the hot water has steamed up and it's caused ice to form on the inside of the jar, whereas the cold water hasn't. It's been about another 15 minutes, so it's about a quarter after. And right now, I'm getting a reading of about 52 degrees on the hot water. That does not seem right, because I'm getting a reading of, well, it keeps climbing, but I'm getting a reading of about 19 degrees right now on the cold water, which also leads me to believe that the container itself is getting cold, but again, it hasn't changed the temperature of the water inside much. It's really hard to get a reading as to where my laser is shining when I put that on there. It's also, it could be if I go up on top. See, it's dropped to -7 degrees on the lid, whereas here it's about -3. So I have this funny feeling that, okay, here's my little experiment still going on. It's been just like an hour and 15 minutes. And if you look real close on the cold, it's got ice crystals forming on the outside, you know, on the inside of the jar, but on the outside of the... And the hot water doesn't look like it's doing much of anything. It's still got stuff inside. I'm gonna it's reading 28 degrees. And that's reading about 15 degrees. Which doesn't make sense, because both of them should be froze by now. But I'll let them sit here for a little bit longer, and we'll see what happens. I just wanted to look real quick. Yeah, that's still fluid inside. You can kind of see it sloshing around. And this, I think, has got a layer on top already. So we may prove that hot water does not freeze faster than cold water. Okay, it's been just about 2 hours since I started this. The hot water is froze across the top, but you can see there's air bubbles in there. So it's not froze very thick. And the cold water, you can see there's a bubble floating around in there. But it's pretty solid. Whereas the hot water, it's just got a thin thin layer of ice. Now I've already broken through that thin layer of ice on there, so I'm going to call this experiment done, and I'm going to say that hot water freezes faster than cold water. That myth has been busted.